Isomerism in coordination chemistry. Coordination compounds also exhibit the two types of isomerisms. That is the structural isomerism and the stereoisomerism. For the structural isomerism, we know that the complex has the same number of atoms, the same number and type of atoms, but different connectivities. For this one, same number of atoms, same number of and types of atoms, but different connectivities. That means if we are looking at structural isomerisms, we are looking at how the ligands and the metal atoms are connected to each other. And now for the stereoisomerisms, this for the complex has the same number and types of atoms, the same number and types of atoms, and the same connectivity, but different arrangement in space. So now, we were looking at the structural isomerisms. Under structural isomerisms, we have ionization isomerisms, hydration isomerisms, ligand or linkage isomerism. And I'm going to explain this very well with examples for you to get it very clearly so that you'll be able to identify any type of isomerism when you are given coordination complexes. So for the structural isomerisms, I think we have two more left and I'll be treating them very well. Let's deal with let's deal with 1, 2, 3. Let's deal with this one we are done. Then we continue with the others. So ionization isomerism. For ionization isomerism, look at these complexes. Can you see this and this complex and this complex? What do you see? Can you see any difference? Here we have SO4 as a ligand, and here we have SO4 as a counter ion. Mind you, if you have a coordination, for everything that is in the square bracket, make up the coordination sphere. Anything outside the square bracket is a counter ion. So we have counter ion and a ligand exchanging their places. If we have counter ion and a ligand exchanging their places, then we know that the kind of isomerism exhibited is ionization isomerism. So here we have CO bonded to NH3, CO bonded to NH3. We have SO4 and B3 here. And here we have B3 inside. That means SO4 has changed its position with Br. So this means we have ionization isomerisms here. This pair of complexes exhibit ionization isomerism. Let's look at hydration isomerism. For hydration isomerism is a type of ionization isomerism, but in this case we have water acting as a ligand, and we have water acting as a ligand, and in the other case it is acting as a water of hydration. You see, we have water here as a ligand. We do not have water outside here, but for this complex we have water inside as a ligand, and we have water here acting as a water of crystallization. So if you see any pair of complexes behaving this way, then the type of isomerism display here is hydration isomerism. Hydration isomerism and ionization isomerism are the same, but just that it is hydration when we are talking about water. If we see water acting as a ligand and at the same time acting as a water of crystallization, then we call it hydration isomerism. So let's look at ligand or linkage isomerism. For this one, we have a ligand in a complex. Even if it's not a ligand, even if we have more than one ligand, at least one of the ligand have to point in different ways. Point of attachment of at least one of the ligands has to differ. If you see this, if you look at this complex, NO2, here we have ONO. So in this place, we have N coming first before O. N coming first before O means that it is nitrogen that has donated a lone pair of electrons to form a complex with cobalt. And this place, we have O coming first, showing that it is O, oxygen, that has donated a lone pair of electrons to form a complex with cobalt. So in this place, the donor atom is nitrogen, and in this complex, the donor atom is oxygen. So if we see ligands behaving in this way, then the type of isomerism displayed here is ligand or linkage isomerism. Let me give you a clue. Anytime you see an ambiguous ligand, then be expecting ligand or linkage isomerism. And the list of, the type of ambiguous ligand that we have are the common ones. We have thiocyanate, SCN, thiocyanate. We can have a point, in which sulfur will be forming a complex with the metal atom. And we can also have a point in which nitrogen will be forming a bond with the metal atom. So in this place, we have sulfur as a donor atom, and in this place, we have nitrogen as a donor atom. So if you look at this one, nitro, NO2, nitro, the donor atoms is nitrogen. And if you look at nitrito, ONO, nitrito, the donor atom is oxygen. So anytime you see, this kind of ligands, be possibly looking out for linkage or ligand isomerism mostly. So now let's look at the other two. Okay, for the other two types of the structural isomerism, we have the coordination isomerism and the polymerization isomerism. That means in coordination complexes, the types of structural isomerism that we can get are ionization, hydration, ligand or linkage isomerism. And okay, let's continue with this. So coordination isomerism. For this kind of isomerism, look at this complex very carefully. Look at the pair of complexes here very carefully. This is number one and this is number two. You will see that from the first pair of complex, you see cobalt here coming first, and here chromium here coming second. We have cobalt forming a complex with ammonia, and here we have chromium forming a complex with cyanide. The second one, we have chromium forming a complex with ammonia, and followed by cobalt forming a complex with cyanide. You could see that from the first pair of complexes, we have cobalt forming a bond with ammonia, forming a complex with ammonia. And from the second one, we have cobalt forming a complex with cyanide. And from the first complex, you could see that chromium, this is where the problem comes from. Look at the metal atoms. They exchange ligands. The metal atom exchange ligands. If exchange ligands. So anytime you see something like this, then possibly, is the complexes are exhibiting coordination isomerism. So changes of ligand between the cationic part and the anionic part of the complex. So I hope this is clear. You could see that we have cobalt here forming with ammonia, but here the two metal atoms that are in this complex are what and what? We have cobalt and chromium. So at the end of the day, cobalt and chromium are going to exchange their places. So where chromium were, we will have where cobalt was, we will have chromium to come there, and where chromium is, we have cobalt to come there. So that means at the end of the day, they exchange their ligands. So if you see something like this, then we have coordination isomerism. Look at number two. You can figure this out by yourself. You will see that we have zinc here, copper here, zinc here. They exchange their positions. So you will see that this is clearly coordination isomerism. So the other type, the last type of structural isomerism that is left is polymerization isomerism. I brought this so that you know that we also have something like this. But mostly we look at the ionization, the hydration, the ligand and the linkage, and the coordination isomerism. Those are the most common ones. For this one, you can also look at, you can also research on it. And it's just simply that it is possible. It's one of the possible isomerism in coordination chemistry, in which the complexes will have the same empirical formula but different molecular weight. So this is just basically what is behind polymerization isomerism. So thank you for watching. Kindly like this video and subscribe to my channel for more. And before we conclude on structural isomerisms and coordination chemistry, I have an example. I have examples here. I want you to try them and let me see your answers in the comment section. Yes, you are to identify the kind of isomerism displays, exhibited in the pair of the following complexes. So try your best to watch the part 2 that is going to base on stereo isomerisms. So thank you for watching. Bye.